we are just applying the knowledge even further. This was a hard lesson for a lot of people. So we just need to re-go over a few things. So remember that we learned about central angles last time. A central angle is an angle that is formed by two radii drawn on our circle that start in the, so our angle starts in the middle of our circle here. So central angle, center of our circle. So a central angle will start at the center of our circle. So I'm going to put a theta right there. So we have this central angle, there's a radius, and it forms our central angle since it started at the center of our circle and worked its way out. And we did learn a rule. If we have a central angle, then it's going to do what? Can anyone tell me? Yes. Yep, good. So it's going to equal its intercepted arc. So right there we have arc that this central angle is intercepting, so this is arc AB. So we learned the rule. If we have a central angle, then that central angle will equal its intercepted arc. So theta will equal arc AB. They're equal in size. Okay? And then we also learned about inscribed angles. So an inscribed angle is an angle formed on the circle, starting on the outside of the circle, as long as it does not start in the center of our circle. So right here we have our inscribed angle. Right here it is. Notice it started on the outside of our circle, here to here, but it did not start in the center, because if it did, it would be a central angle. So an inscribed angle is any angle formed on the circle other than the center. So with that being said, we learned something. We learned a rule with inscribed angles. So we do have an arc, just like with a central angle, we do have an intercepted arc with an inscribed angle, but the rule is different. So can anyone remember the rule?
Oh,
yeah?
Arc AB over 2
is equal to? Good. So this angle is going to be half the amount of that arc. So once again, this angle is half the amount of that arc. So you could write that in a rule as saying theta is equal to the arc AB divided by 2, because that angle is half the size of that arc. Or you could say, okay, that if we multiply that angle by 2, it's going to equal that arc, right? Okay, so 2 times by theta is equal to arc AB. Same thing, I'm just writing them differently. So just keep in mind, guys, this angle is half the amount of that arc. An inscribed angle is half the amount of its intercepted arc. Okay, so now with that being said, we also need to remember that halfway around a circle, if we have a circle and a diameter drawn halfway around would equal 180 degrees. We're going to use that a lot today. And then all the way around a circle would be 360 degrees. So just remember these 4 things. Let's just start doing some examples. All right, so looking at this, it says solve for x. What you need to understand is solving for x, all you have to do is set up a true statement and solve for x. If your statement's different than mine, that's fine. You just got to set up a true statement, and if your statement is true, you're going to find the same answer for x. So looking at this example here, we have this arc is x plus 2, this arc is x minus 3, and I also have this diameter drawn here, so I have a half a circle here. So once again, we have to just set up a true statement and then solve for x. So does everybody see the half circle here? So that will equal 180 degrees, right? A half a circle is equal to 180 degrees. So is it a true statement to say that amount, x plus 2 plus x minus 3, better equal 180 degrees? Yes? So let's set that up then. Just set up a true statement. That is true. X plus 2 plus x minus 3 better be equal to 180 degrees. That is a true statement. So we're going to get the right answer. So now piece by piece, we'll just solve for x. So I'm going to combine my terms over here. So we have 2x, and then 2 minus 3 is negative 1, which is equal to 180 degrees. And now piece by piece, we'll just solve for x. So I'm going to add 1 to both sides, add 1. So I have 2x is equal to 181 degrees. Questions? And continuing solving for x, piece by piece, I'm going to divide both sides by 2. X is equal to 90.5 degrees. Did we solve for x? Yes. And we're done. Set up a true statement, solve for x. You're going to find the right answer if you set up a true statement. Okay, let's do one more and then I'll set you free to work. Okay, this one looks a little bit harder, and it is a little bit harder, but I'm going to give you a hint when you see something like this where to start. So notice we have this circle here. We're solving for x. We have this circle here. We have a couple things. First of all, I always look, okay, so I'm solving for x. Well, I have this inscribed angle right here. It's 3x plus 2. Interesting. So we know that that angle is going to be half the intercepted arc, right? Interesting. Okay. We also have this inscribed angle right here. We know it's 102. So we know that this is going to be half its intercepted arc. So 102 is half of this arc. Arc ABC. And we have this arc right here, which is 62 degrees. We have this arc is 83. So I'm going to give you a hint. First of all, the first thing I always look for is, do I have an inscribed angle that I know for sure that I can use? Because if you do, then you know a lot about the circle. So I'm going to direct your attention right here. We have 102 degrees, right? Everybody see it? So we know that its intercepted arc, which would be from here to here, since it opens up like that, is going to be twice the amount of that. So we know that that blue arc is going to be twice its intercepted arc. So 102 times by 2 will equal 204 degrees. So the entire blue arc here is 204 degrees. Well, we know this piece of the arc is 83 degrees. So can we find from here to here? Yeah, we'll take the full amount, which is 204, and we'll subtract off 83 degrees. Is everybody following me? Okay. So with that, then we're going to get 121 degrees. So this piece from here to here is 121 degrees. So from here to here is 121. All right, so now looking around our circle, we have this piece is 121 from here to here. We have this piece is 83. That's from here to here. We know this piece from here to here is 62. Well, do we know everything around the full circle except for that piece right there?
Yes.
Yes. So we can find that piece though, because a full circle will add up to be what? 360 degrees. So I'm going to do 360 degrees minus 121 degrees minus 83 degrees minus 62 degrees. So we do that, 360 minus 121 minus 83 minus 62, you'll get 94 degrees. So this piece now, I just figured it out, from here to here is 94 degrees. Okay, so we have enough information to continue solving this. So once again, we're ultimately trying to solve for x. So I'm going to go to the only place that I even have an x. It's right there at that inscribed angle. So we have to use that inscribed angle now and set up a true statement. So we know that that is an inscribed angle amongst this arc right here. Well, what is that entire arc? It's going to be 94 plus 62. Does everybody see that? 94 plus 62. So the full pink arc is 94 degrees plus 62 degrees. So 156. So our entire pink arc is 156. So I'm going to just write that. So now I'm going to set up a true statement. Would it be true to say 156 divided by 2 is equal to 3x plus 2? Would it also be true to say 2 times by 3x plus 2 will equal that arc? Yes. Twice times an inscribed angle will equal its intercepted arc. So that's the way I'm going to do it. So I'm saying, setting up a true statement now. 2 times by 3x plus 2. So 2 times by our intercepted angle, our inscribed angle, will equal its intercepted arc. So that's equal to the arc 156. And now we'll just solve for x. That's a true statement. Does everybody see the true statement? Solving for x piece by piece now. I'm just going to, there's many ways algebraically to do this. 2 times by 3x is 6x. 2 times by 2 is 4. So we have 6x plus 4 is equal to 156 degrees. And now piece by piece, I'll solve for x. minus 4, minus 4. So we have 6x is equal to 152 degrees. And now piece by piece continuing to solve for x, divide by 6, divide by 6. So x is equal to 25.33 degrees. So we found x. So yeah, this one took a little bit of extra work because we had to go through quite a few steps to get there. But the first thing I always look for is, do I have an inscribed angle that I know for sure that I can use, because we know a lot about its intercepted arc. Yes?
Where did the 2 come from that we did the distributed property?
Oh yeah, okay, so just a reminder of the rule. If we have a circle and an inscribed angle such as theta. So we have this arc from here to here, right? This arc right here. The rule is that this angle is half its intercepted arc. Or you could say 2 times by that angle is equal to the arc. So that's why we're doing 2 times by the intercepted angle, because this times 2 is equal to the intercepted arc. That's a true statement. Yes?
Where did the 56 come from?
The 156?
Yeah, the 156.
So we were adding up the entire arc here. So do you see the pink arc?
Yeah.
We know this piece of the pink arc was 94. This piece of the pink arc was 62. So the entire amount, which is what we needed, because that's the arc that this angle is intercepting, would be 156. You've got to do the full arc, which is 94 plus 62. Okay. Any other questions? These are all good ones. Okay. Do these problems on the green worksheet, 9 through 12. Okay, moving on. So, once again, an inscribed angle is equal to half its intercepted arc, or 2 times that angle will equal the arc. Okay, so that angle is only half as big as the arc. Okay, so I'm going to do just one more example for you to be able to finish up the green worksheet, because it's asking you for a little bit more, but it has the same idea. So it says find angle DCB. So I'm going to just draw that out right now. It's asking me to find angle DCB. So we're trying to find this angle right here. Well, we know that angle is 2x plus 10, but we have no idea what x is, right? We could find it if we did know what x is, though. So we're going to have to solve for x first, and then find that angle. So I'm going to solve for x first. Now, we can solve for x by setting up any true statement and solving for x. So once again, there's different ways of doing this, many different ways. So now notice here, I see that the first thing I'm going to point out here is, well, we have an inscribed angle. So right there's our inscribed angle, and so it has an intercepted arc from here to here. So there's its intercepted arc. Do we know a lot about its intercepted arc? We know that it's x plus 3, that portion of it, but it's all of it. So we also know it's 16x plus 2. So the entire pink arc here is our intercepted arc of this inscribed angle. So the entire arc would be this amount plus this amount, right? Does everybody see that? So I'm going to go ahead and add those up. So the entire arc is going to be this amount, which is 16x minus 2. So 16x minus 2 plus this amount, which is x plus 3. So the entire arc is 17x, combining like terms here, 17x plus 1. So I'm just going to write that over here just to keep you looking in the right place. So this entire arc we just found, we added up the 2 pieces we were given, and we know the entire arc is 17x plus 1. Okay, what do we know about an intercepted angle with an inscribed angle with its intercepted arc? It's half of it, or 2 times the inscribed angle will equal the arc. So would it be a true statement to say 2 times by 2x plus 10 will equal 17x plus 1? 2 times the inscribed angle, isn't that the inscribed angle? Everybody, is equal to its intercepted arc. The intercepted arc we found was that full amount, which added up to be 17x plus 1. Is this a true statement? Okay, so now solve for x piece by piece. So we'll do 2 times by 2, x is 4x, 2 times by 10 is 20, So we have 4x plus 20 is equal to 17x plus 1, and now piece by piece we'll solve for x. So I'm going to subtract 4x, subtract 4x from both sides, so that leaves me with 20 is equal to 13x plus 1. Piece by piece, solving for x, subtract 1, subtract 1. So I have 19 is equal to 13x. And then solving for x, our last step is to divide both sides by 13. So we get x is equal to, what is it approximately? Approximately 1.5, okay. So 1.5, so x is equal to 1.5. Well, that's not our completely final answer. Yes, we need that, but we're gonna find angle DCB, which we know is right here. So we know the angle DCB is 2x plus 10. We do know x now, so x is 1.5, so just substitute it in. So we have 2 times by 1.5 plus 10, so that is equal to 13. So angle DCB is equal to 13. Any questions? 13. So yes, you might have to solve for x to be able to find an arc or find an angle, but just set up a true statement and solve for x. And then also keep in mind there is a difference between angle DCB and arc DCB, so just be careful when you're doing the assignment, okay? So angle is the inside of this figure here, and arc is on the outside of the circle. Okay, so do problems 13 through 16 on green, and then I'll set you free to work on the pink worksheet, okay? Because it's nothing new, but just making sure we can apply it. Okay, so if you watch these really carefully, then hopefully it will just make sure that you know what you're doing for pink. Okay, so it says find question mark and then find x. So looking at this circle, once again, my first hint, the first thing I go to is if I'm given an inscribed angle that I know for sure, I'm going to use that because that's a lot of information on a circle. So looking at this, the first thing I see here is that I have 100 degrees. That is an inscribed angle. So we know that that amount is half of its intercepted arc. The intercepted arc for 100 degrees is from here to here. So if our angle is half of the intercepted arc, then how much is our arc? 2 times by 100, right? So it's going to be 200. So that blue arc is 200 degrees total. Okay, so now with that being said, look at our circle. Look around our circle. We know this piece is 57. We know from here to here is 200. Can we find question marks now? It's quick, right? That was really quick. A full circle will add up to be 360 degrees. So 360 degrees minus that part of our circle, which is 200, minus this part of our circle, which is 57 degrees. And that will leave us with question mark. So we would get 103 degrees. So question mark is 103 degrees. Okay, done with question mark. Now it says find x. Well, x is an inscribed angle. X is an inscribed angle, and it opens up on this arc from here to here. Okay, so we know that an inscribed angle is equal to half its intercepted arc. So the intercepted arc is 57 degrees plus 103 degrees. That is 160 degrees, right? Does everybody see how that full arc is 160 degrees? So we could say 160 degrees divided by 2 is equal to x, because we know that this inscribed angle x is going to be half the amount that the intercepted arc is. So that's 80 degrees. So is 80 half of 160? Yes, so we did it right. Any questions? Yes, sir? Okay, yeah, so this amount, this is 100 degrees, right? And its intercepted arc, at an inscribed angle, its intercepted arc is from here to here. So we will multiply that by 2 to find the arc. Good question. Okay. All right, so we found x, and done. And last one, it says, find the measure, this little m stands for measure, so find the measure of arc BC. So I'm going to draw that in. So we're trying to find the arc BC. Well, we know that arc BC is 3x minus 2, but we have no idea what x is. So to be able to find the arc, we're going to first have to find x. So we have to find x by setting up a true statement and solving for x piece by piece. So I see that I have an inscribed angle here, and it's opening up on arc AB. So would it be a true statement to say would it be a true statement to say x plus 2 multiplied by 2 will equal that arc?
Yes.
Yes. So I'm going to do 2 times by x plus 2, because that will equal arc AB. So that gives me 2x plus 4. So arc AB is 2x plus 4. Now look all the way around our circle. We know what every piece is, right? And so all those will add up to be 360 degrees. So that's how I'm going to do it. I'm going to leave myself some room, so I'll do it down here. So we know that 3x plus 2, that piece, 3x minus 2 plus 2x plus 4. So this entire circle will add up to be 360 degrees, and then plus 5x plus 1 would equal 360 degrees. That's a true statement. So now I'll solve for x piece by piece. I'll combine all like terms. So I'm going to combine all my x's. Positive 3 plus 2 x's. 3x plus 2 x's is 5 x's. Plus another 5 x's is 10 x's. I just took care of my x's. And then I'm doing negative 2 plus 4, which is positive 2. 2 plus 1 is 3. So plus 3 is equal to 360 degrees. And piece by piece, I'm going to solve for x. Subtract 3 from both sides. So 10x is equal to 357 degrees. And piece by piece, solving for x, divide by 10, divide by 10. So x is equal to 35.7 degrees. Well, that's not what we were trying to find. We did have to find that, though, to be able to find arc BC. Well, we just found x. It's 35.7, so just plug it in. So 3 times by 35.7, which was x, minus 2. So that arc is going to be equal to, let's do that real quick, 105.1. So that's our final answer. 105.1 degrees. We had to solve for x by setting up a true statement, and then once we found x, then we could find either the arc or the angle needed. So now you're going to be able to finish up the pink worksheet. That is due next time. So make sure you have it done. Hand in the green worksheet when you finished it. That's due today. Make sure you have this done.